this is for Year 10 Methods Pathways. We're going to continue with 4.5, okay? We're going to look at question 2, okay? So question 1 was all about using the cross method for factorizing these trinomials, okay? Whether it's monic, which is these ones, or non-monic, which is these ones with the numbers in front of the squared term, okay? Now, question 2 is all about the same. I'm going to ignore splitting the middle term, okay? Because I don't think it's important to use the second method. We're only going to use cross method. Alright, so let's continue. We'll have a go at another negative one, okay? We'll do 2g. So we've got 3k squared minus 11k plus 6. Alright, now we need to factorize this using the cross product method. What are the factors of 3k? Okay, we're lucky here. There's only one possibility. It's 3k and k. Okay, since k is a prime, 3 is a prime number, there's only one multiplication that gives me a 3. Okay. What a multiplication that gives me 6? What multipliers give you 6? But add together give you negative 11k. Okay. Again, you can't look at this in traditional cross product manner. So you're not strictly saying what factors give me 6 and multiply give you, or what factors give me 6 but add to give me negative 11, okay? We have to consider that these aren't even, so it's not x and x. So let's just list out all the factors, okay? And we do need to consider the negatives. So we can have 6, 1, 1, 6, 6, 1, 1, 6. Okay, we can have a negative here. We can have a negative here, we can have a negative here, we can have a negative here. 2, 3, 3, 2, 2, 3, 3, 2. We can have a negative here. We can have, actually, if we look at this carefully, you notice how that's a positive 6. The only way to get a positive at the end is if they're both negative, so I don't need to consider that this many factors. Negative, negative, or negative, 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 negative. Okay, let's see which one works. So 3 minus 6. No, it doesn't work. That's minus 9. Minus 18 minus 1. No, it doesn't work. Minus 9. So 3 is a 9. Minus 9 minus 2. Yes, that works. Okay. So, and some of these you can do in your head. I'm not suggesting that, oh, I have to show all of the possible factors. If you find a factor that works, or you find one that works in your head, write it down, try it, double try it. So double try it. 9 times negative 3, 3 times 3 is 9, negative 9, negative 9, negative 2 is negative 11. So double check it works. Then I just read across 3k minus 2, oops, 3k minus 2, and k minus 3. Okay, that's the factorization. We're done. But if it asks you to solve, k minus 3 equals 0, k equals 2/3, and k equals 3. Alright, we're done. Alright, let's do one more so that we're totally confident, okay? So, we'll do 2h. 2h. So if I have 11a squared minus a minus 12, and I want to factorize this using the cross product method, 11's a prime number, so that makes life a lot easier because we only have one combination. That gives me 11a squared, which is 11a and a. We've got negatives here. Okay, so we've got 3, 4, 4, 3, 3, 4, 4, 3, 6, 1, 1, 6, 6, 1, 1, 6, and what's my other possibility? We got 3, 4, 12, 1, 1, 12, 12, 1, 1, 12. Okay, before I, slave away writing all the possible factors, because that's super tedious, we can get an idea of which one actually works. Obviously 11 times anything, any of these numbers, won't work because we're going to get a massive number. Okay, and we've only got an a here, so that's not going to compensate for whatever that does. Okay, so we can automatically assume that these won't work. We can try 11 times 6 won't work. 11 times 6 won't work. Again, we're going to have massive numbers. 11 times 1 is 11 minus 6. So these won't work. These won't work. I can automatically, in my mind, reject these ones. The 12 and the 1s will work, okay? So before I even write like which one's negative, which one's positive, you need to find which one makes sense. If I have 112 and 111, wouldn't that work? It would, because I can make the 12 negative, and I can make the a, or the term here, positive. I got 11a plus negative 12a, which is negative a. So this factor works. Double check it works. You go 11 times 1 is 11a, and then you've got negative 12a, so that's negative a. Okay, so we've got 11a minus 12a plus 1. Okay, and that's the factorization. To solve it, if it was to solve question, then a equals 12, 1, 11, and a equals negative 1. Yeah, so two solutions. Now let's go, so that's the gist of completing the square, okay? You don't always have to list out all the factors. Just find two factors that make sense given what our, what our possible factors for the a squared term are. Now, let's look at question 3 is basically asking you to find the value of a and b. So if I have x squared plus 2x plus a, if I expand the second, the other side, I get x squared plus 2 bx plus b squared. I can cancel the x squared off both sides because I can say, subtract both sides by x squared, and I'm left with 2x plus a, and I got 2bx plus b squared. Now I can do something called equating coefficients. I can compare apples of apples, oranges of oranges. So we've got an x squared term, and we've got a constant term. So we can compare the coefficients of the x term and the constant term together. Okay, so we can say they're equal. Okay, so I can say that 2x equals, not 2x, 2 equals 2b, because we're talking about the coefficient of x, not x itself, and a equals b squared. Okay, so I'm saying that these two are equal, these two are equal, because that's logical, right? Okay, so if you have two terms on one side, two terms on the other side, we can say that the coefficients are equal. So I just made them equal. So we'll solve it. This b equals 1. When I solve that, we've given that b equals 1, a equals b squared, which is 1 squared, which is 1. Okay, so b equals 1, a equals 1, and we're done. Okay, so you can approach all the problems like those. Okay, you read what the coefficients are. Question 4, factorize the following expressions, if possible, when completing the square. Okay, we'll do 4a. So 4a is, we've got 2x squared minus 6x plus 1. Now, when completing the square, we need to make sure the x squared term is 1. So in order to do that, we need to take a factor out. We take a factor of 2 out. We go x squared minus 3x plus a half. Okay, it works because when you times 2 by a half, or 2 lots of a half, you get 1 back. Okay, so you just put it over the whatever you're taking out. Okay, now completing the square, very simple. I use the shortcut method. Now, you notice how I took in the 2 out. You just put double bracket, okay? So I'm going to use the scaffold that I normally use for completing square. I've got a negative 3 on the coefficient of the x term, so I'll just go half of that. So negative 3 over 2. I square that term, so it'll be positive 9 over 4. Drop the plus a half. And so that's inside bracket. What I do now is I need to simplify the fractions. Okay, so we've got negative 9 on 4 plus a half, so they're both going to 4. A half becomes 2 on 4, so negative 2 on 4, negative 9 on 4, so negative so 2 on 4, negative 9 on 4 is positive, not positive, negative 7 over 4. And all I'm using is dots. So this is the complete the square step, and this is the dot step. So when we use the dots, I've got a 2 at the front. I've got x minus 3 on 2 minus the square root of that thing, okay? So it's a root 7, square root of 4 is 2, x minus 3 on 2 plus root 7 on 2. So all I'm doing is using complete the square method. The only difference is between completing square you've done in the past and complete the square you've done now is that we've got possible fractions inside the bracket, okay, and you need to deal with it. And we've dealt with fractions before, so this shouldn't be anything new to you. Let's just say, okay, what if it says solve? So if you factorize it, that's it. You leave the answer like that. What if it says solve? To solve, simply you go, okay, to solve it, okay, you see the 2 at the front, it's times with these 2 factors. You can divide both sides by 2 so it goes away. Or you can just ignore it, okay? We're interested in what makes these 2 equal 0 because of the null factor law. So x would equal the opposite signs of these. So it'll be 3 on 2 plus root 7 on 2, or 3 on 2, opposite sign of that, minus root 7 on 2. Now you can be very fancy and go x3 plus root 7 on 2 and 3 minus root 7 on 2. Some people like to write 3 plus or minus root 7 on 2. Okay, it doesn't matter, whatever you write, these 3 versions are correct. Okay, I'm just not sure which one the book writes. Let's do another one, just to be confident with some of these. I'll do question I. Okay, so 4i. So 3x squared minus 6x plus 5. 3x squared. 3x squared minus 6x plus 5. I'm going to take a factor of 3 out. Again, when you complete the square, you always make sure the number in front of the x squared is 1. So in order to get a 1, you get to take the factor of 3 out. Minus 3 goes into 6x twice, 2x times. And then 5 doesn't go in 3 perfectly, so you just go 5 of 3. Okay? Because when you multiply it, you get plus positive 5 again. Again, I'm put a big brackets, square brackets. Do the scaffold because I want to complete the square inside. So you got x minus 1. Half of 2 is negative 2 is negative 1. Square of negative 1 is positive 1. Then plus 5 over 3. Okay. What I'm doing now is I complete the square. So I dots inside. Okay. So you got x minus 1 squared. Now on 3, 1 is the same as 3 on 3. So you got negative 3 on 3 plus 5 on 3. And negative 3 on 3 plus 5 on 3 is positive 2 over 3. Now, we've got an interesting scenario in that the dots won't work. Can you see this is a plus? We're relying on dots working if this is a minus, and that's a plus. So there's we cannot factorize further. Okay, so we cannot factorize further. Cannot factorize